solve any interpolation problem, first we need to check out whether it is a equal interval interpolation problem or unequal interval interpolation problem. That means when you see the x values difference, if there is a common difference between two consecutive x values, say for example in this case the difference between this is 1 and difference between these two consecutive x values is also 1. The same way is 4 to 5. So this type of problems we call it as the equal interval interpolation problems. So after this, first step is to check it whether the problem is equal interval type or unequal interval type. If it is equal interval type, then we have to check it whether we have to use a forward difference method or the backward difference method. This depends on the value of x at which you are expecting the answer is close to the starting point or close to the end point. Say for example in this problem we have 1.4. This 1.4 is close to the starting point 1 rather than the end point 5. So in such scenario, better to use a forward formula for an accurate solution. Even you can use backward, but the solution error will be more in this case. So these 4 points has to be observed in every interpolation problem. That is, the first step is whether the x values are equispaced values, they have the common step size, or the difference between two consecutive values is same or not. Then we have to see what is the value of y expecting, at which point they are expecting y value, and that x point is close to the starting point or close to the end point. Depending on whether close to the end point or the beginning point, we'll use either forward form or a backward form. In this case 1.4 is close to the beginning point, so we use a forward difference formula, Newton's forward difference formula. For that, first we need to construct the difference table. So let me write the values of x and y, whatever we have in this. X values and the corresponding y values. X values we have 1, 2, 3, 4 and 5. Corresponding y values, if you look at, they are 10 and 26, 58, 112 and 194. Now we have to calculate the differences, finite differences. First order difference is indicated by del y. The difference is simple, the difference between these two values, but take it y1 minus y0, not in this way. 26 minus 10 you are supposed to take, it's going to be 16. Next 58 minus 26, which gives you 32. Next 112 minus 58, and we simplify 112 minus 58, which comes as 54. Similarly 194 minus 112 will give you 82. These are first order differences. Next move to second order differences, delta square y. 32 minus 16, which is 16. 54 minus 32, we simplify 54 minus 32 is 22. 82 minus 54, which is 28. Next third order differences, delta cube y, then we get it 22 minus 16, which is 6, and 28 minus 22, which is 6. The last fourth order direct difference, 6 minus 6, which is 0. Observe, when you have 5 observations, the difference will go up to power 4. Okay, after that it becomes 0. Delta power 5, if you calculate, it will be 0. So now, because we are using forward difference formula in this problem, because 1.4 is close to the begin point 1, so we have to take the first values in this difference table. That is, these values we wanted to use. This is y0, and this value is going to be delta y0. The first value is going to be delta square y0, and this is delta cube y0, and this value is delta power 4 y0. For every problem, the construction of the table and the values in case of forward difference formula is going to be topmost values, and then in case of backward formula also the table construction procedure is same, but the values we are going to use is the last values in case of backward difference formula. Now we know the values and everything. Now let us use the forward difference formula. We are using forward difference formula, not backward. Forward difference formula. So in this case, I have 5 values. Fine. Let me write the formula first. Y of x is equals to y naught plus p into delta y naught. In case of forward difference formula, p into p minus 1 by 2 factorial into delta square y naught, p into p minus 1 into p minus 2 divided by 3 factorial into delta cube y naught plus p into p minus 1, p minus 2, p minus 3 by 4 factorial into delta power 4 y naught. Now from the table you will get all the values y naught, delta square y naught, delta power 5 and everything. But what about this p? P is calculated based on the step size and point x minus x naught by h. If you look at the given table, x value is 1.4. They're expecting at x is equals to 1.4. And what is the common difference between x values? That is the step size h, which is 1 in this case, and the starting point is 1. Looking at the table in this cell, let me write it. H is equals to 1, this one, and this value is x naught, which is 1, and x minus x, this value at which point you're expecting the output y, that's the x value. So p you can calculate in this way, x minus x naught by h, so that x minus x naught by h, which is 1.4 is x, 1 is x naught, and h is 1, 0.24. Now we have to substitute everything in the formula. That is what is the formula? We have y of x is equals to y naught, right? Y naught value, what is y naught value? 10. So this is going to be 10. P is 0.4 into delta y naught. We got delta y naught value as 16 plus p into p minus 1 divided by 2 factorial into delta square y naught. Delta square y naught value we got it as 6. Next term, p into p minus 1 into p minus 2 divided by 3 factorial into delta cube y naught. Delta cube y naught value is 6. I think y naught is 10. This is also 16 and this is 6. The last one, delta power 4, is 0, so no need to substitute. And when you simplify, it comes as 14.864. This is the way how you are supposed to use Newton's forward formula by using the difference table to get the y of 1.4.